So last week we introduced the equation for speed. We said that speed is distance divided by time. Okay, so that means the distance travelled divided by the time taken to travel that distance. So I'm going to provide you with some videos of some experiments for finding the speed of various different things. Normally you would do this in the classroom, but I'm going to have to show you some experiments, then I'm going to get you to do something at home. So in this set of activities, you will measure some speeds. You'll also start thinking about the factors that will affect the accuracy with which you make your measurements. So we've got 5 activities, well we've got 6 in total, but 5 of them are measuring speed. So you can see I've done the first one for you there. So this is just the speed of a toy car travelling down a ramp. Now some of these you can do yourselves at home as well. So I've got a toy car on a ramp, and the distance travelled, I've got a set of results there, 1 metre, and the time it took to travel that 1 metre is 0.2 seconds. So to find the speed of that car, we do the distance divided by the time. So 1 divided by 0.2, which when you put that into your calculator, or you can do it in your head, it comes to 5 metres per second, m/s. The second one, speed of a falling ball, what we use is a distance meter. So that distance meter can tell us how far down the floor is. So if we measure the distance with that distance meter and we drop the ball from that height is the distance that it travels. So again, I'll put in some demonstration results. So distance traveled 1 meter again. And the time it takes for that is 0.22 seconds. So speed is distance divided by time. So I'm sure you can do this yourself. But the distance is 1 divided by 0.22. And if you put that into your calculator, I'll just pause a second while you do that. The average speed should come to 4.54 meters per second. The next one was the speed of a marble on a curved track. So we've got a curved track, so it curves downwards and then back upwards. And a marble is dropped from the top one side and it moves along until it gets to the top of the other side. So what we do is we measure the distance travelled that the track is. So you use a tape measure for this rather than a ruler, because a ruler is straight and we want something that can curve. So distance travelled in meters is about half a meter, is about 0.45 meters. And the time taken for it to travel that is 1.2 seconds. So if we find the speed of that, it's distance, so 0.45 divided by the time, which is 1.2. So 0.45 divided by 1.2, and that comes to, when you put it into your calculator, 0.375 meters per second. The next one, and some of you did this when you did your friction experiments, is the speed of a parachute. So what we have is a parachute attached to a little cork. And again, we use that distance meter to measure the distance that that parachute will be dropping. So the distance that it dropped, we dropped it from 1 meter. And the time it took to drop that 1 meter was 0.66 seconds. So to find the speed of that parachute, it's distance divided by time. So 1 divided by 0.66, and that comes to 1.51 meters per second. Activity 5, you'll like my diagram here. Speed of a person walking. So we use a trundle wheel for this. Now trundle wheel is sort of a wheel on a stick, and every time it turns one rotation, that's 1 meter. So some of you might have used trundle wheels in the past, some of you might not have. So what you do is every time it clicks, that's 1 rotation and 1 meter walked. So you can walk until it maybe clicks 3 times, so that's 3 meters that you've walked. And you time how long it takes you to walk 3 meters. So for example, distance traveled 3 meters, time taken 2.5 seconds for that. So speed is distance divided by time. So 3 divided by 2.5, which comes to 1.2 meters per second. And the final activity is reaction time. So basically what this is it's something that one person presses one of the buttons, and when that presses, it lights up on a little panel. And another person watches that light, and as soon as that light lights up, they click their button, which is this one here. And the faster they click the button when they see the light, the faster the reaction time. So just some demonstration reaction times here. I've got some written down: 0.250 seconds, 0.194 seconds, 0.210 seconds. And to find the average reaction time, to find the average of anything, we add them up and divide them by the amount that there are, so divided by 3. And the average for that is 0.22 seconds. Okay, so what I'm going to do, and you can read the instructions later, is I'm going to get you guys to have a go at doing your own speed experiment at home. It could be measuring a distance that a little toy car travels. You can measure the time that a little car travels in a certain distance. So you can measure the distance using a ruler, use your phone to measure the time and then find the speed. Or I will use my dogs and I'll measure how far they travel, and then I'll measure the time it takes for them to travel that far and then find the speed of them. Just to answer the following questions about the accuracy and reliability of this experiment. So in activities 1 to 5, your measurement of speed may be inaccurate. Suggest why. So this could be a number of different ways. It could be difficult to measure the exact distances that were travelled, or, and this is the main one, difficult to measure the time because the times are so short. Press start and stop. There's not much time in between them, so human reaction time is a problem there. Number 2, using exactly the same equipment, suggest how you might go about improving the reliability of your results. Repeating results is a great way to improve reliability. So repeat them and find the average. And number 3, explain why electronic timing is used in international athletics races instead of stopwatches. Well, remember, in athletics races, sometimes the time between first and second place is so small, it's very difficult, and humans just can't react that quickly. So you need to use electronic timers for that.